Hey, how's everyone doing tonight? So, first on the agenda, lots of stuff I want to talk about again tonight. Fermilabs posted this video on April 1st, and I almost was like expecting an April Fool's joke. Um, but yeah, let's check this out. We always love Don Lincoln, Dr. Don. So let's see what Dr. Don has to say for us.
Many of you who watch this channel actually know quite a bit about physics, which makes sense, of course, because, well, you're smart and that whole physics is everything thing. And you ask questions about things that don't make sense to you. A super common question is, how can a photon, which has no mass, have momentum? That's a good question with a lot of complexity in the answer, so let's dive into it.
Let's dive into it. All right. Well, this is pretty funny because it's like I felt like I was wading in the shallow end of the pool, honestly, with this dive. I'm not gonna watch the whole thing. We'll just kind of go through it. He goes over P equals mv, which is the momentum formula. Mass times velocity is your momentum. Then he shows, how we get kinetic energy and how we relate kinetic energy and momentum by these formulas. It's all high school algebra and doesn't really get into the real physics of it. Oh, this is great. So this is what I love is these segments that they put in. Right?
And that is that these equations aren't completely true. That's right. You've been lied to. Wake up, sheeple. The man is lying to you. Man, I have always...
Dude, that was like the worst Alex Jones impression ever. You gotta laugh at that stuff, dude. Look at
true. That's right. You've been lied to. Wake up, sheeple. The man is lying to you.
Come on.
Man, I have always
wanted
to say that in the video. Why should others have all the fun? Of course, like a lot of times when people toss around the word sheeple, what I just said was a little misleading, and the real story is a bit complicated. The real truth is that those equations are special cases that only work for objects with mass that is moving at slow speeds. And of course, I should be upfront that when I say the man is someone like me. So I guess you have to decide whether to believe me or not. But you should, because, I know stuff. And it's way cool.
But you should. Please. I encourage people, don't believe me and go I love it nothing more than when people correct me and show me when we're wrong on this channel. And that's always the best is when we get people who are smarter than us to come in here and correct us. Because that's what this is all about. That's what science it should be all about. In my opinion, science is the belief in questioning experts. So
now comes the next surprise, and that surprise involves Einstein. Of course, Einstein was all about moving at super fast speeds near the speed of light, so you know that he's going to pop up in any discussion involving photons and momentum. And when you think about Einstein, you almost always think about his famous equation, E equals mc squared. And guess what? That equation's wrong too. Come on, sheeple, wake up. How long are you going to stay fooled? Okay, I promise. That's the last rant. But the rant has a super...
Those are his rants, dude. Are you serious, dude? Oh my God, this is like a bad dream, man.
Tiny kernel of truth. E equals mc squared is also an approximate equation and one that only works for objects with mass that are stationary. It's not a general equation, and it doesn't work for massless objects, nor objects that are moving. In fact, I made a whole video just digging into the limitations of this equation. The link is down there in the description. Watch it later if you're interested. So now we're ready to get to the truth. I put the three equations I've mentioned so far here. E equals mc squared, P equals mv, and Ke equals p squared divided by 2m. And all of these equations are just fine and correct but they are all equations that only describe objects with mass
that move slowly.
Those equations fail in other situations. It turns out that there is a more general equation that works for all situations, and it looks kind of like Einstein's famous equation. This equation is
again
energy squared equals the momentum times the speed of light squared plus the mass of the object times the speed of light squared, all squared. E squared equals PC squared plus MC squared, all squared. Now this equation works for everything: massive objects, massless objects, things moving near the speed of light, things moving at the speed of light, and things that are stationary. And we can look at the special...
these are just so, it's just, yeah, it's so cringe and so sigh. It's like, come on, Don. Come on, Don. This is not a deep dive. This is not a diving in. This is a wading, shallow wade through the pool, man. Like, this is not you got Fermilabs is a $60 billion industry, man. We're supposed to be on the cutting edge of current science and technology. You guys don't even like take UFOs seriously, and this is your like conspiracy rants, dude. Like that's the rants that this guy goes on. Nothing to say. It is, God damn. It's like the amount of money that they're getting to the facilities and the equipment that they have. If we could just get some new young minds in there to give me a management position at Fermilab in 5 years, and I'll have. You're going to see some serious, research going on into things that need research, not this. I mean, some of the stuff's good. Some of these theories and ideas are good, but there's not really exploring the fundamental core of physics. This is old stuff. Dirac had the relativistic equation, and the Dirac equation is, an extension of all this stuff, right? They left out so much stuff. I don't even know where to begin. And this is his explanation for light being used. Does light have momentum? And this is photons having momentum. And there's so much more physics going on here, guys. I remember all the leak Mirabeau stuff that I showed you guys. They actually power Dr. Lake Mirabeau. He was a NASA scientist, and I talk about this guy all the time. He had this whole book with these ideas of, using microwaves to fly these saucer-shaped, UFOs and stuff. Amazing technologies. I showed some of the live videos of this stuff actually working, demonstrating it, Here, we'll show this one. Here's microwave light being used to create momentum pulses. Basically creating a shock wave that boils, vaporizes, or turns from to gas to plasma, I guess. Adds a ton of momentum and energy density to this small amount of air on the inside of this disk with a laser pulse, and that pushes off and gives some of its momentum to the projectile. And there was lots of research done throughout the 90s into, this type of technology. And then, there was videos talking about this on TV and television shows. Even Elon Musk had some stuff to say about it. This is
3, 2, 1, 0. And we have liftoff.
The beamed energy thing is interesting. I think it is a worthy area of research. So I think it's worth trying to make something work. Try to get something to orbit or a really high delta velocity with beamed energy. and see how well does it work in practice. I mean, I do think this. I mean, I'll state some concerns, but these concerns are not meant to say that we shouldn't work on them. I preface it by saying we should work on it. I think that there are some scaling challenges with beamed energy. You have to say, what's the actual power output you need to send, say, a Falcon 9 class vehicle to orbit? And it's a very, very big number. Like you start needing like, whoa, we need like the power of like the Eastern Seaboard, to sort of send something Falcon, they call it Falcon Heavy class, what do you need to send something like that to orbit? It's really a huge amount of energy. Or a huge amount of power, to be precise. Like, actually, the power level you need is no, you don't need like arguing not that much on an energy basis, but you can't like tell everyone to turn their lights off in Florida. So then you need like a huge power plant or a huge capacitor bank or a huge high power density battery array. So I'd like to see how this, how well does it scale. And then you say, what's the cost of that, the huge power plant and the huge laser array and that kind of thing, and how does that compare to the cost per unit mass if you just carry your own oxygen with you and have a lower ISP and don't do any of those things?
All right, interesting. Great arguments from business standpoint on why we don't have this technology in the public and why Elon Musk and SpaceX aren't currently using it to send payloads to orbit. So, you remember in the other videos of this stuff working, I gotta find that video now if we can. You can see I don't know where the heck that is now. But there's a video of this stuff working in the laboratory. I'm going to get into a whole bunch of other stuff about photon momentum and photon propulsion, light-based propulsion technologies that just make this April Fool's joke from Fermilabs look exactly what it is. It's what's my day job right now? I run my own company, and I'm a self-employed contractor. I write contracts for work, and I complete contracts, mostly construction right now, because that's just what I do. I would build my way around this guy, hands down. I would work circles around this dude in a lab or at his house. But yeah, I do a lot of complex projects on my day job, and I have to do this because I've been dealing I've been dealing with alien scientists where we like basically do deep dives, not shallow end and wades in the pool. We do deep dives on the physics of classified programs and technologies and trying to explore these subjects more scientifically. And that's caused a lot of problems for people in the intelligence community who want to keep these things a secret, when there's people like me digging it all back up again and keep talking about it and doing deep dives on it. And all they can do is shadow ban the material because for the sheeple who want to watch Don Lincoln and think that they're getting fully informed on photon momentum and propulsion, it's kind of a joke. Let's talk about this a little bit and some of the physics of this and where to find that information. I have a whole book on this. If anyone is interested, there's a great book by Rick Marabo. If you guys find this book, the Flight Handbook, LTI, the Hypersonic Flight Handbook. This book fortunately, I got a copy that's scanned, but it's it's boycotted. It's kind of black market right now. I was lucky enough to get a hold of it, but because they might have a reprint of it. I think they might be doing a reprint, but the cost of this right now is off the charts to get like an actual, physical copy of the book. It's out of print because it went classified, I believe, and just not. And then it's super expensive because of the content that's in it, and maybe we'll show you some of that, but that's the book you want to get for all the math and all the research that's been done into this, that really goes and does the deep dive on the physics and stuff, for those of you who are interested in that. And then Don Lincoln can talk about his projects, but really, realistically, this momentum thing is not normally thought of in terms of that. P equals mv is a really archaic and original way of thinking about it, and the way they teach you, probably junior senior year of physics in school, is you learn more about the Hamiltonian operators and the physics of where it's no longer these easy. This is the deep dive where it gets a little crazy if you don't know what all these symbols mean, but it takes a while to learn this stuff and go through and learn the math, but it's more exact to once you understand the complexities of what's really going on in these energy exchanges and stuff. But the basis of it is, it starts with these things called this Hamiltonian operator here. And this Hamiltonian operator is that, again, it goes back to that p squared over 2m thing that he kind of briefly talks about. And that is your kinetic energy plus v of x, which is your potential, So it's kinetic plus potential energy. And this is this operator called the Hamiltonian. And basically, if you know the kinetic and the potential energy of a system, you can describe its motion through what's called a differential equation. And this is the differential. It's that the energy flow. This is the total energy right here. Is this H unit, and that energy flows in the system from the potential to the kinetic, back and forth in some way. So there's a joke in physics that the solution to most every problem in physics is 0, 1, and the simple harmonic oscillator, right? 0, 1, and the simple harmonic oscillator. So this is the solution to this differential equation is oftentimes a simple harmonic oscillator. It's not always so simple, because the potentials and some of these other things can often do change. That once you add in all the potentials in a system, like if you were to take the Hamiltonian of a universe and make this more and more complex and add more and more terms, you could eventually get like the total energy of the universe in terms of, and how it's constantly oscillating between potential and kinetic energy. Yes. Yeah. So Mirabeau doesn't use the momentum of the light, but the momentum of the matter around the craft. Yeah. So that's a good distinction in the physics of what's going on here. And so Don Lincoln in the video, for to be clear, he's just thinking about it inside a box. He's thinking about it inside the box of photons, and using photons for pure momentum flight and just photon energy. So he's not thinking outside of very, very small and limited box in the within the physics models. So to be clear, he doesn't get anything wrong. He's just very elementary and very limited in the way he's thinking about it. Yeah. So dude, if we can get in touch with Elon to try Mirabeau's stuff, to see if we can scale it or change, some of it around to make it, and do the calculations to see what it would cost, to scale it. They had I want to show the video of that Project Skyvault test, right? Michael, if you want to jump on here and add anything to this conversation, that would be awesome. I'm just going to post the link right here. If anyone else, wants to get on and talk, who knows more about the physics and wants to get into this. Project Skyvault. So Mirabo. Oh, this is it right here.
As the beam pulses, it strips air molecules of their electrons, creating an explosive plasma that propels the craft from below.
Gosh. How about that?
Nice catch.
What do you figure? 40 feet?
Yeah, that was about 40 feet.
To achieve the dreams of science fiction, to boldly go beyond our solar system, we will have to revolutionize space propulsion. In a few isolated labs around the world, scientists are struggling to invent the future. Working at a missile range in White Sands, New Mexico, Dr. Lake Mirabeau carefully hones tiny prototypes of a vehicle unlike anything ever put into space. Mirabeau imagines spacecraft propelled by powerful laser beams.
A high-powered pulsed laser beam comes in the backside here, reflects off this parabola, and focuses inside of the engine here. The light is focused to such a huge intensity that it just breaks down the air here and blasts out a very strong shock wave. And in so doing, propels the model forward in a series of pulses. The temperatures inside here, when the laser is on for about 18 microseconds, are of the order of 10,000 to 30,000 Kelvin, which is 4 to 6 times hotter than the surface of the sun.
Aspects of Mirabeau's design go back to the 1950s, including its flying saucer-like shape. His innovation is to use an energy beam as propulsion.
This is where I wish, they only show this for a second because this is like where the magic happens.
His innovation.
What is this? What are these things in this rack unit? So this looks like a voltage meter or output meter. This looks like a splitter, or I don't know. Like, love to know all the equipment that they have here and that they're using. And plus, you see all these support trailers.
Having to lift vast amounts of fuel above the atmosphere. Mirabeau is using a laser developed by the now defunct Strategic Defense Initiative, known in the 1980s as the Star Wars program. With the laser pointed upward, a high platform must be maneuvered overhead to block the beam. This laser is so intense, it could accidentally cripple a satellite orbiting above.
Maybe 45.
Accidentally or purposely.
Fried. I think it's definitely fried.
So look at the size of this support building that's right here next to whatever this operation is that they're doing, and I really want to know some specs on the energy, the energy capabilities, because this has always been the argument. People are like, oh, this technology exists, but then then there's the people that claim that it can do incredible things on a whole nother scale, and that's the issue, scaling it. Where is the technology at, and how does it work scaling it? I mean, look at the size of these support structures. This is the thing that just runs the office, but it's got all these cabling going to this larger building, which looks like it looks like a power plant. It's got these giant smokestacks on it. I don't know. It looks like a power plant that's providing the power to this. So if that's the kind of power plant they need to fly, these little desktop aluminum trinket discs, well, good luck to the engineers. Honestly. Exactly. Yeah. Good luck lifting a Saturn V rocket. Yeah, good luck lifting much. Yeah, it's not the space elevator is a different concept, by the way. So that's like this whole idea that there's a spot in space that you can sink stuff to where it just stays in a stationary point above of the Earth, and it will just follow in space at that orbit. And if you were to extend a strand down to that Earth from that point in space, then you could basically get up to space with the space elevator. You could basically take an elevator all the way up to space, and then you could fall back to Earth. And if you push yourself and enough, you might be able to fall around the Earth and get into an orbit. Just fall into an orbit just from space. So it'll be a new way to put this is cool. Elevator to space. And they're talking about using like graphene
space
strands.
Exploration. Right now.
There's all these different ideas that people have for getting to space and putting us in space, including the rotor. What's the throwing objects into space? Spin launch. Yeah, this spin launch. So that's just, you're building up a ton of momentum and then just releasing it. But man, if you were just a little bit too early or a little bit too late in that release. You guys seen this? This is what they want to build versus what they, I don't know if is this what they have? Is this the real deal? This is the real one, right? Look at the amount of money that they put into this to hurl objects into space with a giant arm. Crazy stuff, huh? It only gets it so far up into the air, though, and then this booster rocket takes over. So it takes a lot of it's just taking a lot of the early launch momentum out of the missile part. A lot of the weight of the missile is just to get it going. Like most of the fuel's burned up lifting more fuel. Like you need to have more fuel just to lift the fuel, just to lift you into space. And it's just like this game where you have to chase it down on a pursuit curve. But man, cool stuff. That's one idea. Anybody else got any crazy ideas for how to get stuff into space. Throw some ideas in the chat. How did I get on Alien Scientists, dude? I don't know, man. Were you watching Baby Shark? That's his logo. Dennis Bank, cool. Welcome here, and I'm glad to have you here, man. You learned some cool stuff. So another method for light propulsion that I did want to talk about was this thing talked about in one of the chapters of Paul Laviolette's book on Secrets of Anti-Gravity, and he talked about microwave phase conjugation. And optical phase conjugation is a really cool phenomenon. We've talked about it a couple times on this program. It's shown here in this video with this mirror. They have an ordinary mirror with a reflected beam, and it blocks out the light with this frosted cup, which obscures the beam and just blurs the image. And then when they use a barium titanate crystal, see, it's got this phase reflection. It's literally this quantum material that where everything reflects on the quantum level. So like phase conjugate mirror, right? So this is a good example. So it can reverse it. Like a conventional mirror will bounce the wave, and the reflected wave will come back looking like this, right? But the phase conjugate mirror will reflect it back exactly the same. So, and it's also for the incident angle. So if you shine light on this way, normal mirror will bounce off and go that way. But a phase conjugate mirror, the light bouncing this way will actually bounce right back in the same direction of the incident angle. So it bounces. So if it bounces, light comes in this way, it bounces back that way off this phase conjugate mirror. And it's true for all those angles. That results in this sort of reflected wave that looks like that. And so what that does is basically that frosted glass that separates that and sends all those light signals going in all different directions, it will reflect those back to the points of origin after it goes into resonance. And that will reverse the image, and it'll be able to reflect it through the frosted cup and back onto the wall. And it is able to resolve itself after a little bit of time for the crystal to do the quantum calculation. It's literally some of the basis of quantum computers. And these materials are called ferroelectrics. Is one word. Ferroelectric is certain materials have spontaneous electric polarization that can be reversed by the application of an external electric field. So all ferroelectrics are also pyroelectric, which is a property of certain crystals which are naturally electrically polarized, and as a result contain large electric fields. So these types of materials were known about and were being researched actually at Bonson Labs. So Bonson Labs was another video of mine. If you go on here and search for BAHNSON, you'll find this video of Townsend Brown and some of his electrogravitics research that was funded in the 1950s at Bonson Labs in North Carolina. And they did a number of these experiments on these dishes, but they had a number of scientists come and visit and talk to them about different ideas and various concepts and things to try. And they often took video. This is a record, a video record of all these interactions, and these people would often take video of important things. I guess, throughout important events throughout the research that was done there, and one of the important things was the chalkboard. Anytime scientists would come through and they'd write up things on the chalkboard, they would take video of that as well. And in one of these slides, I don't know where it is now, but you can see, like, off to the side really quickly in one of the discussions that they were having, they talk about barium titanate and ferroelectrics, and it's mentioned on the board in the background. So they knew about this as early as 1950s with some of the anti-gravity research that was being done out at Bonson Labs. We know that much, but it's just like crazy. Where did that research go, and what happened during the 60s and 70s? Because there's like 2 decades where there's a lot of stuff that happened. It turns out that they basically determined that this was an ion wind effect, and that wasn't real true anti-gravity, and they identified a lot of other ideas in the process, but kind of exhausted this idea, but also kept the research classified and the knowledge classified, and they were applying it to other types of systems, such as the B-2 bomber, and stuff like that we know about. So it's just interesting, the history that was going on throughout that. And then I guess you get into, I'm doing a whole history on this. There was these guys, Luigi Rota and Edward Farrow, in 1913 that were experimenting with the Biefeld-Brown like airplane effects, like these ion winds were well known about, and they were experimenting with some of these and building a whole aircraft hull based on this ion wind idea, like flying an electric lightning bolt, how they didn't electrocute themselves. Put a pilot in there, have to be remote controlled and stuff. So Thomas Townsend Brown, there's machine ordered parts. Tesla had his own ideas about it, but I wanted to talk about this guy. Edward Mills Purcell he won the Nobel Prize for NMR, nuclear magnetic resonance, in 1946, so that the year before Roswell happened. This was the Nobel Prize, and they were starting to study the fact that atoms have subatomic resonances, and arrays of atoms can do weird things, and just doing things with special geometry can affect the electromagnetic field. So they wanted to learn more about this whole electromagnetic spectrum and how materials interacted with it. And so they started up this whole CIA project called Project Rainbow to investigate this stuff. Woo, 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 woo. Now we're getting to the woo-woo stuff, right? Not really. This is like legit research that went on, and this is where metamaterials were essentially first developed, before they were really coined that or known about or talked about. And learned a lot about how these resonant materials work to do weird things optically, and they can be used to bend light. Oh, this is the part in the Bonson Labs experiment. So right here, barium titanate, and they show it, polytopes, and describing some of the physics of what's going on. Artificial dielectrics, the vacuum chamber experiments. But yeah, after 1950s, it went into some of this other research. So two of the scientists that visited over here. This is Cecil Dewitt right here. And here she is visiting the Bonson Labs in one of these slides, and with her husband, Bryce Dewitt. And Bryce Dewitt, I think that's Bryce Dewitt right there. Bryce Dewitt was part of this invisible college, and that was a group of businessmen and scientists that were investigating a lot of this anti-gravity and other stuff during the 1950s and 60s. Dewitt, he published a paper in 1966 on superconductors and gravitational drag, and this started what I believe was the research into rotating Mercury, spin gravity research that went on at General Electric with Henry William Wallace in Valley Forge, Pennsylvania during the 1960s, which could be potentially related to, this Nazi Bell stuff and this Kecksburg UFO incident on December 9th, 1965, and a crash of an acorn type shaped saucer. And again, there was a number of UFO crash sites that witnesses have reported with a metal, like liquid metal, leaking out of the craft. Jonathan Wygant is one Disclosure Project witness I distinctly recall, who reported, being in the military and responding to a UFO crash site where there was liquid metal leaking out of the craft. So then in the 70s, you had, early 70s, 1972, Project Outgrowth started. And this was out of Edwards Air Force Base in California. And it was, they wanted to grow beyond rockets. That was the whole idea of this outgrowth, is they're outgrowthing the research to go beyond rockets. And there's some other guys that wrote on this and wrote PhD theses on this and then got funding and stuff that I've come across over the years. One is John T. Watson, and had some ideas. The Alzafon stuff in the 80s, where they got back into this nuclear magnetic spin resonance and these spin resonant materials. And then in the 90s, of course, with Project GRASP and the Podkletnov rotating superconductors research, which I think stemmed out of, Bryce Dewitt published the Superconductors and Gravitational Drag in 1966. So it's sort of research that was being done, that's being, I don't know if this is just an extension of maybe what they already had done with the mercury plasmas and that rotating superconducting plasmas and stuff like that. And then you get into the late 90s. So right around, this stuff was going on early 90s, mid 90s. 94 is when Alcubierre's warp drive paper comes out and really changes the direction of how the physicists are thinking about and approaching the problem. Not all of them. A lot of people were like myself, were like, warp drive, this sounds like too Star Trek and fantasy and crazy to be like, realistic. And I was still digging down all these old rabbit holes to try to find out what was going on with those. Also, 1980s, late 1980s, out of the Star Wars program, those lasers, they were trying to find other uses and research for, those capabilities that they went and invested all that money in to build, these lasers and stuff. They started doing the Lake Marabou lightcraft, laser propulsion, and microwave beam, plasma shockwave research. And that went into this, this kind of stuff with the directed airflows and the supercavitated air spikes and stuff like that research. But also, during the 90s, you had Lockheed Martin hiring Bernard Haish, a physicist out of Caltech, to do a lot of research on quantum vacuum hypothesis. And, of course, Haish wrote a number of papers with Dr. Hal Puthoff and did a lot of research on this space-time metric engineering stuff, which Sal Pays used as the basis for those U.S. Navy patents that we've been talking about recently. This dynamic Casmir effect, and using mirrors and the squeezed vacuum states, very similar to this. The Pays patents with this PZT. This one with the room temperature superconductor using this PZT. Lead zirconium titanate piezoelectric material. There's other research that we found using polariton condensate to generate room temperature superconductors as well. So there's some similar overlap in the physics going on here. These dimensional crystals may play a role. There's a lot of research that was, being done into this stuff. U.S. Air Force, Wright State, they have, I looked up these guys. These are the papers that he's written on non-destructive terahertz imaging for aerospace applications. Non-destructive terahertz imaging for aerospace applications, submillimeter wave imaging techniques for non-destructive aerospace materials evaluation, non-destructive materials characterization using submillimeter wave imaging, and spectral imaging in the terahertz region for aerospace NDE applications. So it looks like they were using this surface plasma and polariton stuff for wave imaging and stuff. Apparently, they used the technology to resonate the paint layers on an aircraft hull so that they can see beneath the aircraft hull and check for if it's rusting out or has damage beneath the aircraft hull. They can be able to detect it without damaging the paint, without like taking the paint off and having to repaint it, which can cost money. But yeah, it's a lot of interesting research going on. That guy was involved in a lot of classified stuff because he got arrested taking papers home from work, and we covered that. But some of the this stuff could maybe be repurposed if you were to think of this in terms of warp drive capabilities, potentially. But yeah, I cover all this stuff and some really neat technologies in my briefing that I put together. We need to write another Roosevelt letter, like the scientific community came together and wrote like this letter to Roosevelt in 1939, begging him to, start the Manhattan Project. Essentially, they said, "Oh, this guy Enrico Fermi discovered, he just successfully built the first nuclear reactor, this nuclear pile. When they put then they took all the control rods out, it started, producing a small nuclear chain reaction that was sustainable. And that's when they realized, oh God, the nuclear age has dawned, and it's only a matter of time before someone figures out how to use this to make a bomb. And we need to be the first ones to do it so that we can control the world. And, the rest is history. Manhattan Project was started. It was funded with, tons of money, and employed over 100,000 scientists at its peak. this is what we need right now for the UAP technologies, and a serious scientific research panel that can look into this stuff and really dig and do a deep dive, because there's tons that could be researched. And when I look at this Fermilab video with Don Lincoln, thinking that these people get, their funding's like 60 billion a year or something ridiculous, and it's just like to think what we could be accomplishing and could be doing, and the videos that we could be making. If I had 60 billion in funding per year, and the facilities like the professional, I could do 10-minute videos on photon momentum and all this stuff that would just,
Any of you who watched,
oh my God. Anyways, we could maybe dive into the Hamiltonian mechanics and really do like a little weighting, at least show people how to get to the deep water, and that, it's not like to be super afraid of. Some of the math can be intimidating sometimes, but it's just a process of learning it and having it explained to you, and you can learn it. It's not that difficult. Michio Kaku charges $50,000 to $100,000 for a live event, and he charges $30,000 to $50,000. Can you believe this guy? Man, I would love to have a conversation with this dude if we could pull it off, man. It's funny. Anyways, I wanted to show this. This is a good video, and I wanted to go over some of this stuff. So let's. I want to play this. This is a rare 1994 presentation by Hal Puthoff. I want to go back to some key stuff that was going on around that time.
As we all know, there are problems with fossil fuel sources, which we presently use, pollution byproducts. There's certainly problems with the nuclear power plants, especially in the United States. There's it's now essentially impossible to build a nuclear power plant. So people in the energy industry are out searching for alternatives. And of course, some of these are familiar: solar energy, thermonuclear fusion. In the beginning, thermonuclear fusion looked like it would be a great boon, but you're probably familiar with the joke that goes around: thermonuclear fusion looks great about 15 years in the future, but then it's always looked great about 15 years in the future. Capillary fusion is...
That was 1994, and this is still amazingly true today.
A different form of fusion that may work. There's a lot of controversy about so-called cold fusion, under non-thermonuclear conditions. But the one I'm going to talk about, which I think has great promise, is a so-called zero-point energy extraction. I'll explain what I mean by zero-point energy. It really is the energy of so-called empty space. The concept of empty space has gone through several shifts over the past couple thousand years. For example, Democritus said empty space was a void. Otherwise, how could there be room for the atoms to move around in? But then Aristotle came along and said, no, empty space must not really be empty, because we have heat and light, and it must propagate through something. Finally, this was codified last century by Maxwell in electromagnetic theory, saying, well, if electromagnetic waves are waves, then like water waves, they must have something to propagate in, so there must be an ether. But then in special relativity, when attempts were made to try to measure velocity through this ether, it couldn't be done. And so with special relativity and the Michelson-Morley experiment, people said, okay, there is no ether. Empty space is really empty. But then it was only 10 years later, Einstein himself, in developing general relativity, ended up having space-time that could be distorted and warped. And by the time he got finished describing what general relativity had to say about space, with all these properties of being warped and distorted, Einstein himself said, well, then space isn't empty. Introduced the term metric, but basically that sort of brought the idea of a full space back. So Einstein didn't really get rid of it except for a few years. Then finally, with quantum theory, that's when it became absolutely clear that empty space was not empty. There are vacuum fluctuations, particles come out of the vacuum and then annihilate and go back into the vacuum. So it's now recognized by quantum theorists that empty space is very full, very active. What do I mean by that? Let's say we have a case of, say, a mass in a spring you pull down and you let it go like that. Or say have a kid on a swing and you give him a push and let go. Classically, we say that the thing will eventually come to rest. The oscillator will come to rest. It comes to rest because there are losses in the system and energy leaves the system and eventually will come to rest. But quantum mechanically, we say that's not the case. That if you excite an oscillator, you push a swing or a pendulum, you do anything like that and let it go, losses will reduce its energy, but it only comes down to a certain minimal amount of energy, and that energy remains. And so everything at the microscopic scale is always fluctuating. In fact, it turns out that, and it's been calculated, in this room, there's enough energy in that volume to evaporate all the world's oceans. And that's not a controversial idea or a fringe idea. In standard quantum mechanics, it's recognized that the energy in even a coffee cup is enough to evaporate all the world's oceans. John Wheeler's calculated, Richard Feynman's calculated it. The question is, can we get at that energy? And for a long time, it's been thought probably not. But as I'll go through in my presentation tomorrow, there's been a history of development where we see that you can get at that energy. I might ask, there's all that energy right there. Where does it come from? And we know where it comes from. Every piece of matter in the universe is fluctuating around, doing its quantum dance. And in so doing, it radiates energy out. And then every other atom is sitting in that radiation field and absorbing it, and that causes it to jump around and therefore radiate. So it's basically the electromagnetic equivalent of putting a microphone by a speaker and getting the squeal. The particle fluctuations generate the fields cause the particles to fluctuate, and you can do the calculation and show that that accounts for where the vacuum fluctuations come from. It's a giant cosmological feedback system, and we've published that in Physical Review, the details on it. Now you might say, if there's all that energy, even right here in the room, why don't we notice it? Well, in fact, we do. Experiment any of you can do to prove that that energy is really there. Suppose you're on a bus or a train. It takes off with a jerk, and you fall back on the floor. What is the force that knocked you down? I mean, it's a big force to knock you down. Well, it's that as the train or the bus tried to accelerate you, you ran in to the wall of vacuum fluctuations. and there was a resisting wind from the vacuum that held you back and knocked you down. It turns out that that resistance to accelerating through the vacuum energy is proportional to acceleration. So unlike ordinary wind, if you're just moving in a constant velocity, you don't feel it. But if something tries to accelerate you, you do feel it, and it holds you back. And so the reason Newton's law says force equals mass times acceleration, the reason that when you apply a force, you get an acceleration, is that you have to apply a force proportional to acceleration in order to overcome the vacuum energy holding you back, which is also proportional to acceleration. So actually, there's no more ubiquitous constant phenomena. Every time you move your hand, you feel the vacuum. So the energy is very palpable. We just published this in Physical Review in February of this year. And so it was very well received. There was a 2-page write-up in Science Magazine and also in Scientific American. And those are very conservative publications in the United States, and yet still they were interested and published about it.
Does this close the loop in terms of a universal theory?
Well, from our standpoint, the vacuum fluctuations do provide a unifying
Field theory.
Field theory. I've already shown in earlier work that gravitation can be accounted for, and gravitational mass can be accounted for on the basis of interaction of particles with the vacuum fluctuations. And then in this paper, we found that the inertial mass came out to be the same as the gravitational mass. And that's known empirically, but from a philosophical standpoint, it's never known why the inertial mass and the gravitational mass should be the same. And the answer is they both arise from interacting with the vacuum fluctuations, and it fixes them to be the same.
All right. So these vacuum fluctuations apparently link us all together. You know, empty space is really not empty. It's full of stuff. And basically the entire energy of the universe is contained inside every atom, apparently. The atoms of an atom worth of space. It's crazy stuff, man. This quantum vacuum is quite the thing. So this standard model of physics, we have this very interesting model where we got all these particles. You know, there's 3 tiers of them, the up and down quarks. Then there's this cousin, a little heavier on this next level called the charm and strange quarks. And then this top and bottom quarks on the heaviest level. And then there's no quarks that we really can see or know about beyond those 3 pairs. You know, so there's the three tiers. And each tier has an electron. This is like a heavy electron called a muon. And then there's a super heavy electron called a tau particle. And then each one of those has an associated neutrino particle, which is like this interaction ghost interaction carrier in quantum physics. It's a very strange particle, these neutrinos. Still not, sold on exactly how they fit into the model. And, even in Phoenix theory, Ken's explanation of the neutrino, I was still curious about that and how it worked into the greater equation of everything. But basically, the science of this, right? If you want to go back to what he's saying about John Wheeler and Feynman, these guys were some of the greatest minds physics has ever seen. And Wheeler just knows so much, man. He was just a beast. Really just prided himself in knowing everything about everything. But he wrote a number of things. It from bit is my favorite, though. You know, it from bit theory is this idea that every item of the physical world has at its bottom an immaterial source and explanation, that all things physical are information and theoretical in origin, and that this is a participatory universe. Very interesting that we can reduce everything to quantum information, that, you know, maybe it's not just E equals mc squared or E equals h nu or E equals hc over lambda. It's that energy is everywhere all at once, but constantly, you know, being exchanged around in this infinitely interacting sphere of infinities. So this whole idea that it's all information theory and it's all quantum entangled bits of information, and that there's this digital record keeping and all this other stuff that kind of holds the universe and this material thing together. So if we're really just bits on a computer, man, I mean, we can like find some way to hack this quantum code beyond this standard model of physics, which is this it's really a symmetry group if you get into it. This these symmetry groups that are created through the circle symmetry and SU2, SU1. I mean, what is it? SU. SU2, SU3. These special unitary groups in group theory, which are the basis of the standard model of particle physics. So, and it again relates to these Lie groups, which Garrett Lisi does a great job of, you know, explaining and going over in his E8 model of particle physics and his ideas of this exceptionally simple theory of everything. Not really a theory of everything, but it provides this basis for this fractals that can interact on this, you know, infinity sphere, and explain all the different arrangements and how particles arise out of the vacuum through these different space-time rotations. And that is kind of interesting in itself, because when you're talking about, you know, subspaces and you know, higher dimensions and accessing deeper particle physics to do weird things, and because we in the last one we talked about this quantum vacuum breakdown, right? And this thing called the Schwinger limit. That Schwinger was this another brilliant physicist and scientist who incredibly gifted and had lots of contributions to physics, but I wonder if there's any interviews with Julian Schwinger out there. That would be amazing. But essentially, created this Schwinger model, and based on this QED Lagrangian, and this was his idea of how the vacuum broke down on the quantum level. And it exhibits the spontaneous symmetry breaking of the U1 symmetry due to chiral condensate due to a pool of instantons. The photon in this model becomes a massive particle at low temperatures. Interesting. So if you make really low temperatures, you can increase the mass of the photon. Yeah, this Schwinger stuff is super interesting. We gotta do the deep dives on this stuff. Instanton is a notion appearing in theoretical and mathematical physics. An instanton is a classical solution to equations of motion with a finite non-zero action either in quantum mechanics or in quantum field theory. More precisely, it is a solution to the equations of motion of the classical field theory on a Euclidean spacetime. Okay, English, please. Equations of motion on the classical field theory on a Euclidean spacetime. So that's just a fundamental geometry. And such quantum theory solutions to the equations of motion may be thought of as critical points of the action, and the critical points of the action may be local maxima of the action, local minimal, or saddle points. Instantons are important in quantum field theory because they appear in the path integral as leading quantum corrections to the classical behavior of a system, and they can be used to study the tunneling behavior in various systems, such as a Yang-Mills theory. That doesn't make sense. But, well, I will have to read some more papers on these instantons and really try to understand what they kind of mean. But I'm guessing that there's ways to shock the quantum vacuum into doing weird things. And maybe one of those things is rearranging the space-time around the craft so that you can warp and push yourself through that space-time. That would be pretty cool. And I wonder if that would cause radiation burns or any of those weird effects that were reported recently. You guys see that new report that came out? I don't think it could explain the pregnancies, but where the hell is that recent story? God, it's been all over social media. I mean, you want to talk about crazy sheeple conspiracies and stuff. What if some dude's dressing up like aliens and yeah, this is the one. Check this out, guys. Paradigm Shift, $2. Thank you for the super chat. Appreciate. Praise the cash. Praise the cash. Every little bit helps, brother. Thank you for that. Dude, join the chat. I have the discussion here. We're talking about some UFO physics and trying to get about using light as different concepts for using light as propulsion, you know. I didn't really talk about it, but there's this whole idea of using microwave phase conjugation as this way to, you know, have propulsion using microwaves. But Jesus, witness claimed to have sexual encounter with UFOs. You know, imagine that. Like, they had to have done like a DNA test on the pregnancy and been like, nope, you were just banging the neighbor and lied to your husband, and that's really the father. Or I don't know, was it really like they were like, no, this is an alien, and you're now coming with us to, you know, DEFCON 5, or some crazy strategy is blurred. What is it? We can't read it. Oh, thank you, Jason Wetzel, for the super sticker. That $10. That's pretty fresh. If you want to prove that, sequence that baby DNA, you will get your alien existence. Right on, dude. Get that sequenced alien baby DNA. Where the heck are these babies today? Where is the stuff? I know they had to have done that, dude. You call me a number of times. Why don't you jump on the show, dude? Oh man, we should do a whole nother show. We should schedule it for another show. And I tried to get on for the other night and do that Bob Lazar thing. I mean, not the Bob Lazar thing, the John Lear thing, the whole John Lear show. And jump on. Hey, anyone who's just tuning in, here's the link. I'm not like Michio Kaku charging $30,000 per appearance. Maybe someday. Yeah, right. I'll never do that crap, man. What a load of crock. That's how you know things are fake. You gotta pay big fake money for that. Damn, material science, kinetic metamaterials. Anyone got anything cool to say, or you know, want to join in, hang out for a bit? Sticky Marks. Cheerio. Thank you for the 5 London pounds. I'll make sure to buy a pint. Heck yeah. All right. So let's dive into this a little bit more. We got the ferroelectrics, this Hamiltonians, which was a key thing. Look up a video on classical mechanics, maybe. Mechanics, physics. Yeah. So if you do mechanics, physics, what is mechanics? This is a full course on mechanics. This one probably is the best. 4 hours. Yeah. Dive in. You want to get educated. You want to learn some real science. Dive into mechanics. And if you can mathematically come up with a better way to think about these problems than these dudes, man, then, oh, paradigm shift. $20 super chat, man. Amazing. Thank you so much. This is crazy, dude. Thanks, Jay. We're really kicking it off. So I think space-time is non-Euclidean, and what we perceive as electricity is really information. So beings of an advancement of Louisville could theoretically be able to travel between 2 points much faster. Well, electricity is really information. So I think light is an information exchange, and that makes sense. That's kind of how Ken Grigg's model worked with Phoenix theory, which was this idea that you have all these bundles of trapped light, which constitute particles, and they link up in these symmetric ways according to the these simple symmetries, which create the particles. but then when those information exchanges happen, they they create this photon, which links the energy over to a new area, and then that energy travels through the photon to the new location, and it kind of happens instantaneously if you, in terms of the life of the photon, the photon's perspective, the energy travels instantaneously across the vastness of space and time to wherever it ends up impacting, right? So these photons are traveling all through your body, right? All these radio waves, but they don't go into resonance with your body, which is why they go right through your body, and they don't really cause any interference or crazy damage or anything, right? And it's like the photons go to wherever they're going, and then they go into resonance with whatever they hit, and that's when they decide to interact. I mean, they interact with things that they can go into resonance with. So turns out they resonate with the antenna on your radio much better, and especially when you put the right capacitor on there. That basically inside your radio, when you turn that knob, you're turning a veracapacitor, and you're changing the capacitance on the circuit, which changes the frequency that it tunes into on the megahertz spectrum, and you can tune into various radio signals. And but it's all about what we perceive as electricity is a whole nother thing. It's current, like it's current flowing in wires. It's basically, you have potentials. That's the basis of electricity, and the potential causes a flow of current in a circuit. And I want to get into all this. There's lots of resources and books and stuff if you want to get into this. I would definitely dive into videos on this and encourage people to learn more about electricity and light and all the physics of this, because it's important to get these things sorted out and not super mixed up, because it's easy to do that. Would love to join your StreamYard, but this is not in my wheelhouse. I would add to it, but I just have a million questions. I can build houses and make driveways, and I love your channel. Dr. Fox 2000, $10. There's absolutely nothing wrong with building houses and making driveways, man. And a lot of people on here are those kind of people. You got to think about it, right? There were a number of teams of physicists and engineers working on the airplane, the first flight problem, right? But it ended up being two bicycle engineers, two regular dudes that were just really good at building bicycles and had access to a lot of the lightweight parts and materials, that ended up being the dudes that won the competition and won the race, and they're the ones that did it and built the first airplane, the first heavier than air powered flight, and that started the birth and evolution of the airplane as we know it. So it's really nothing wrong with that. Being a bicycle repairman. Not everyone can be Superman in this world and be a scientist, and like every day. It takes a lot of privilege, really, to have grown up and be extended all of the things that go into making a really good scientist. If you really look into it, it's a lot of luck and a lot of privilege. Some of these people just had the unique mindsets that made them really good at analyzing problems and really good at being scientists. But really, a lot of it's privilege. So don't get it twisted either. these guys had access to a lot of materials. They were, making good money selling bikes, during that time, and the bicycle shop obviously provided enough income for them to pursue their other interests and do this. So again, nothing wrong with that. I do construction for work as my day job anyways. So, and that's the way I relate to stuff, is if you can't like actually get down with your hands and build it and explain to other people how to build it and how to do it and replicate it, then you're not doing valuable service, really. And that's what I try to do here, is try to give people some kind of information where they can get, access. A lot of people can go look up, oh, where do I get a phase conjugate mirror for sale? Well, let me go buy some of the stuff, right? Yeah, well, you can get it. Optical phase conjugation. You maybe be able to build this stuff if you did enough research into it, and obviously somebody who's making it for you is building it somewhere, and it'd be cool to go there and figure out how they build it and, do videos on that. There's tons of science here, man. We don't gotta be talking about Newtonian classical mechanics, and we have Lagrangian mechanics. Yeah, so
This has to do with the thermal noise.
No, that's an addition. Who asked the question? Right. That's an addition. When you write down what is the background in the universe, you get two terms. The one term is a 0-point energy. The other term is a thermal background distribution. The reason the 0-point energy is called 0 point is because if you let temperature go all the way to 0, the thermal term will disappear. But at the 0 point, this first term, which we now call 0-point energy, remains. It doesn't depend on the temperature. So the term 0 point and 0-point energy means 0 temperature point.
So you would have 0-point energy at absolute zero.
At absolute zero.
And in the absence of anything else.
That's right. So if you go in the furthest vacuum of outer space and you're hoping to power your spaceship on 0-point energy, you would not have a problem.
Dr. Puthoff, you may know from my papers that I doubt the equality of gravitation and inertial acceleration.
You say you doubt it?
I doubt it.
Doubt it, right.
I have from various observations, stellar observations. Can be because the density, let's say, or viscosity of the ether changes as a result. Also, this equality may change.
Okay, well, in our modeling, I would agree with the first part, and that is if the density of the vacuum fluctuations changes, these will change. But in our model, they change together.
What I have only calculated only is already a deviation of 36% for the Jovian moons. That close already.
I see.
I already have an SDR, and I've played around with it a little bit, but I don't have the transmitter version of it because there's FCC regulations on a lot of that stuff. I only have receive, so all I can do is listen. Currently, I can't tune in certain frequencies and blast them yet. But that would be ideal. Would be the next level of the SDR is to be able to transmit, any frequency, any waveform, any impulse, and also receive. But that stuff's heavily regulated because a lot of it's I won't get into it. Maybe it's bad for me to describe what people are using it for, but should I do it anyway? Yeah, screw it. We don't censor ourselves on this channel, right? Yeah, this is Hal Puthoff from 1994, and a bunch of people asking him questions and stuff. There's Germans and Japanese there who are interested in this. The Japanese have been funding cold fusion research. They're the ones that like put Hal Fleischmann and Pons up in France after they left the United States. So, yeah, that's exactly. I'm not going to say it, but someone else did for me. Is that you can get like any transmitter, right? And get a device that like an SDR, I can set this thing up to just listen for transmitters, and I can just record those signals, and then whatever those codes are, I can replay them with the transmitter. Yep. So you can do you can hack lots of things. I'm not going to tell you what, but
think it over.
Okay. Now, what we're interested here is extracting this energy for use. Now, it's a well-known false idea in physics that, well, we have all this heat energy around us. Why don't we somehow extract that energy for use? But you can prove that it just doesn't work. It would take more energy to get the energy out of the surrounding heat than you would get. And so when it was recognized that zero-point energy was there, it was thought that similarly, it couldn't be extracted. But a researcher at Hughes Laboratory pointed out that there was already an effect in the laboratory which demonstrated that the zero-point energy could be extracted. It's a so-called Casmir effect. Casmir effect is named after Heinrich Casmir, who was research director for many years at Philips Laboratory in the Netherlands. And this is what he noticed. As you know, if you have say a radio, transistor radio, and you take it in your car or go inside of a metal building or inside of a shielded cage, you can't hear the radio stations. The metal shields out the electromagnetic signals. Well, these vacuum fluctuations are electromagnetic signals. And so Casmir realized that if you had a metal enclosure, or say even just a couple of metal plates together, close to each other, that the region in between would be somewhat shielded from the vacuum energy coming from all different directions. It would be somewhat shielded. Well, this energy has radiation pressure, momentum, energy, just like any electromagnetic wave. So between the plates, where some of that energy is shielded out, the energy traveling back and forth puts only a certain amount of radiation pressure outward. But outside, where there is no shielding, you have all the energy pushing in by radiation pressure. And so what happens is that the plates are pushed together. And this is a large force, and it's been measured in the laboratory. The force goes up to 1,000,000 newtons per square meter at close distances. Well, a newton is the weight of a book. A square meter is about a square yard. So it's a big effect. In certain cases, when you're...
what's interesting is that this Casmir effect, there's a maritime analog of it. So like in the ocean, you have all these random waves that are just, the ocean just has all the waves going at once in this sort of big pool of wave motion. And when you have two objects, like they did this with like boats in a tub, and they found that the two boats would have damping of certain frequencies between the boats, and that over time it would cause the boats to like gradually like come together. And they used this as like an analog or an explanation for how gravity is functioning on this quantum level through all this wave motion and structure. Sort of like pushing things together because there's damping in this Casmir force. So that potentially, if you were to figure out a way to damp that Casmir force, maybe you could shut off gravity, right? potentially. That'd be cool.
Bring metal.
And Dan and Jeremiah, welcome to the show. Sorry, like I didn't like introduce you guys. So what's going on? You guys any updates or news?
I'm just looking up MOSFET parts, you know.
Oh, metal oxide semiconductor.
Always got to look at the data sheets, especially
MOSFET.
with your Tesla tech. Your switching speeds. Switching speed is everything. And
are they metal oxide field effects transistors?
Yeah, these ones are. I'm going to be testing out some SiCs pretty soon and swapping out with the standard tech. So, but I have an idea to go.
What got you into using MOSFETs, the power capabilities?
Say again.
What got you into using MOSFETs, the power capabilities, or what?
Well, I had a bunch of them from recycled electronics, and they were just added to my repertoire of various switching components.
All the time, man. Yeah.
What got me into MOSFETs is because they're the best solution for super high-speed, high-power switching when it comes down to
absolutely nothing better.
So
they used to be expensive.
Yes, they did, and now we're on like 7th or 8th generation FET devices from certain companies like IXYS or Fairchild.
Oh, I was gonna say Fairchild. Trying to think of some of the other companies that made those.
International Rectifier.
We used to use the motor. We used to have this motor speed controller. It had about 8 of those on the back, and they were all attached to a big heat sink. And we put the solution on there, the heat transfer, the conducting heat transfer, that white stuff. I can't remember what it's called anymore. It's like 20 years ago.
It's called thermal paste.
Yes, thermal paste. And man, I'll tell you what, man, when one of those things would explode, 2 other ones explode. It sounded like M80s going off. It was crazy. But those boards generated incredible power. And you're right, the switching power and speed of those things is second to none. And for what I was building them for, we needed it. But yeah, I miss the days of working on microelectronics and shit like that. I never get to touch anything like that anymore. What's up, Jeremy? Sorry about the John Lear thing. I had thought you stated that we were doing 6 p.m. Dude, and you were like, no. And I had that girl with me, and I scheduled everything around that. She's moved out since then. So it's all good. So she won't be bothering me about any time I can do a John Lear show again. And it was, what'd you say? It was 9 p.m. Eastern Standard Time. We're now midnight and 9 Pacific Time. It was so confusing or whatever. We'll do it again. Everybody's doing a John Lear tribute. No one can do one as good as us, though, I don't think. Yeah. Because we'll actually tell the truth if you want me to.
I don't know. What do you guys want to do?
Definitely the Godfather conspiracy. I mean, you know, on a night where you want to do that. Hal Puthoff, man, look how young he was there. That was 94, huh? Yeah. I guess he's in his 80s. He's got to be up there. He's about 10 years older than Ed. Ed would be about 73 or 4 right now.
I swear there's a longer version of this where he talks about a breakthrough that happened about 10 years ago.
If there is, you got to record it because they are wiping YouTube out.
Yeah.
I found some of the stuff I've been looking for on Vimeo, man, and I was shocked the other night. I found like 4 videos that I had lost before. Vimeo's got some stuff on it, so you might want to go over there and check. I'm not saying it's over there, but let me see. Can I see who posted the video? Can you go down a little bit so I can see?
Yeah, this is unidentified aerial phenomena.
Okay, I'm not familiar with that channel, but I've probably seen it before.
Let's see what else they got. Oh, they got an Edgar Mitchell interview. They got.
I was gonna say he's probably got tons of stuff. Yeah, keep going through there. Jeez, I saw Clifford Stone now died, even though Clifford Stone
Davis.
was an artist. Everybody's dying.
Good stuff.
John Lear, Clifford Stone, and the other guy was Jordan Maxwell all in a week or so.
It's not the same. I'm trying to get that Project Unity guy on. I'm trying to get a bunch of other people on. I'm setting up more. I got.
What about getting Kevin Day on from the UAP phenomenon? He's one of the better ones to have on, I think. He's one that said it was raining UFOs and he witnessed it.
Wow.
He got a divorce over it. It's changed his life, but he's also running this thing where we should go out there, man. He'll take you out in a boat and stuff. It's expensive and show you exactly where they were.
Relativity theory requires that all events no matter where they're located in.
There's that weirdo Eric Davis.
In warp space. Wait a minute. This guy's features up.
Strange
I won't
cat.
get into a lot of it.
It is definitely
All that weight put into that.
That's the Stargate solution.
Wilson.
Okay, so there's some alternatives. We have my colleague in Longview, Texas, Richard Abusi, got his PhD at Baylor on this. You use negative Casmir vacuum energy in extra space dimensions. This comes from superstring theory. And it turns out that if you apply that to a warp drive, you can get the energy down to negative, the equivalent negative mass of Jupiter. And that's a lot lower. That's about the size of a wormhole, of a wormhole energy requirement. However, these guys found that, Richard and his colleagues found that there's going to be a maximum quantum speed limit for warp drives. It'll be 10 to the 32 times the speed of light. That's 1 followed by 32 zeros times the speed of light. But for all intents and purposes, that's pretty huge. That's pretty big. Harold White, that's Sonny White, my colleague at NASA. We found a way, both of us. I gave him this idea to do the study, and he looked at taking the warp bubble and pulsing it at high frequency so that you can lower the energy demand on average, and you crunch all your energy into a peak pulse width spaced out in very short time intervals. That's what we do in directed energy weapons. That's how you create high-powered laser weapons. A laser like this is powered by batteries. This thing won't be able to produce megawatt power, but I can produce megawatts of peak power if it's pulsed up to megawatts, and the average taken over time is going to be very low energy. So he did an analysis of doing such a thing. He did high-frequency pulsing of the warp bubble. He shrank the thickness of the warp. He increased the warp bubble wall, and he made it thicker. And the result is that the energy of the warp is much smaller.
Oh, Jesus. How are we going to do this, Eric? Producing negative vacuum energy. Now, this is the good stuff right here.
A reduced state energy inside the plates. And here the energy happens to be negative. And it's very weak. It's not usable. But it exists in nature. And we routinely make these in lab. This is a mirror. And if you take a mirror and you accelerate it rapidly through space, it will excite the quantum vacuum fluctuation and create a flux of negative energy. A beam of negative energy will be emanating from in front of its motion. And the best one that we've identified in the last 4 years is a parabolic cylindrical mirror, just like these that are used for solar thermal energy converters. The idea is that you put this in the vacuum of space, and it's going to focus all of the vacuum fluctuations that strike the mirror. They're going to focus along the focal line of the mirror. And Larry Ford at Tufts University did a calculation with his colleague Spader, and they figured out that the energy of the vacuum fluctuations that collects on that focal line is negative. And not only is it negative, it's astronomically negative. I had my student in Georgia Tech do a calculation of a micron size, a mirror, the size of the width of my hair, and we produced like negative 10 to the 30th joules per cubic meter. 1 cubic meter of space contains negative 10 to the 30th joule. So we think we've got the way of producing warp drives and wormholes now. So this will be the way to do it. These processes are going to be weak and difficult to implement. This is really, the negative energy you get out of this is too weak to matter. Okay, if you're going to build a warp drive and a wormhole, you need to be able to detect the negative energy. It's like all radio engineers and light engineers. You have devices that detect the light, tells you how intense and bright it is, what its wavelength is. Or you have radio detectors, radio receivers, that'll tell you FM or AM radio signal, what the broadband wavelength is, and blah, blah, blah. Okay, well, we got to have that for negative energy. And we implement that using what's called a balanced Homodyne detector, which were invented in the early 80s for the purpose of measuring the states of non-classical light. I'm just going to say basically it's, remember that previous graph, that previous thing I showed you, squeeze light? Okay, well, the balanced Homodyne detector was specifically invented to measure this, to see the alternating pulses of negative and positive energy. And in fact, there it is. There's the raw data that was measured in the early 80s of positive, and the negative energy is in that little valley right there. Positive, negative energy, positive, and so forth. And this is called quantum tomography. It's like a CAT scan tomography or positron electron tomography that medical doctors use to scan slices of your body tissue to hunt for tumors and damaged tissues. And so a tomography can see this. And this is a squeezed vacuum state. There's the positive energy there, and the negative energy is this way. Well, the next thing that has not been done yet is doing a quantum tomography of the negative energy inside of a Casmir cavity. And that's what I'm working on with my coworkers at EarthTech now. The idea is to put 2 miniaturized nanoscale photodiodes inside of a cavity, about 1 millimeter on each side, on each plate. And the plates are separated by 1 micrometer, the width of my hair. And I want to make a measurement of the negative energy, and that's what it would look like. This is the computer model simulation of the actual of this version. This is the modified version of that. I'm not going to be able to implement this for this because they're two different systems. So I'm going to have a version of this here, and what it's going to give me is this. And these colored regions represent where the mathematics breaks down right there at stationary modes inside the cavity, and we're not going to be expected to see anything, but the negative energy is going to be observed here. If you insert the nanoprobes inside the cavity, this is how much the nanoprobes will disturb the transverse electric mode inside the cavity. Now that looks like a lot, but it's not. It's only 0.4% disturbance, so that's good. That's actually what we want. Okay, I'm getting close to finishing. This is the toughest problem that we have yet, and I'm not there yet. I'm still dealing with detecting negative energy and making negative energy, producing it and detecting it. We're nowhere near this. How do we construct a wormhole? We don't know how. I mean, Einstein's general theory of relativity, that equation I showed you, doesn't tell you how to do engineering. It just tells you how, it just says if you want to design space-time, you want to design curvature and warps, then it'll tell you what kind of matter you need on that right-hand side, that T tensor. Okay, and we know what that is, but it doesn't tell you how to implement it using technology. That's the problem. It tells you how to predict this stuff, but you don't know how to build it. So we can only speculate. Maybe just take a frame like this of Ford's Fader mirrors. Maybe this is a line of parabolic mirrors all along here, and they're shooting negative energy down to create the spherical throat of the wormhole. And a spaceship just goes through that opening and goes right into the wormhole. Or maybe you might have an array of Ford's Fader mirrors like this, and the negative energy is pulled off the focal lines, and they all concentrate at that little point there, and the rocket's going to have to go into that little hole in the middle. See, the idea, remember, is we got to thread a throat with negative energy in order to push space out, stretch it out, hold it open, and make that hyperspace shortcut so that you can dive into it and come out the other side. See, that's just a fictional diagram of what it looks like in 2 dimensions. Okay, that's what a Flam diagram looks like. Warp drives, again, that's even more speculative. You know, that's the Star Trek warp drive engine from the Next Generation. Unfortunately, we don't know how to do that. We probably are going to have to do something similar to this with the Ford's Fader mirrors. Okay, so let's assume we've already got our warp drive generator, our warp bubble negative energy generator, our detectors. Our engineers have detectors. They can see the negative energy so they can locate it, shape it, position it in the right places, and we're all good and swell. All right, and now we can build the warp drive. Now, what happens when you're going to start flying? When you start flying, you've got a couple pictures. You've got the observer's view. You guys are all the astronomers on the planet Earth. You're looking up in your telescope. You're looking up at the Milky Way at the night sky, and all of a sudden you see this crazy thing. All of a sudden your view is pinched off like this. And then this transition thing goes by you as it moves. And you see this distortion as this thing is transiting across your field of view. And then as it moves away from you, you see that. Well, that's what a warp drive looks like through your telescope. So that's what you would expect to see as an astronomer. If you're sitting in your starship, this is what you're going to see through your forward view window and your rear view window. And this is when you're at stop. You see the stars here and the stars there, forward and aft through your front and back windows. Now, if you're moving at 10 times the light speed, you notice how the stars now collapse down to those regions. And then if you're moving at 100 times light speed, the stars are now bundled up into little balls. They're blue for the blue Doppler shifting going forward and the red Doppler shifting going backwards away from you. For traversable wormholes, if you're inside that throat, this is what you're going to see. You can't navigate that. There's nothing to navigate with here. You're going to have all this distorted light. That's all going to be shoved around and distorted by the negative energy that's holding up the throat. Negative energy is gravitationally repulsive. See, we're all of us are made out of positive energy, like this, the atoms in our bodies and the floor and whatnot. That's gravitationally attractive. That's why the moon, the positive mass of the moon and the positive mass of the earth are gravitationally attracting. But negative energy is repulsive. It pushes things away. So light gets just pushed away into these distorted shapes here. Okay, well, we come to the conclusion. So what do I have left to do? I've given you the grand tour. And right now, Earth Tech, which is my employer, we're looking at the critical technology issues. And we've started an experimental program to produce negative vacuum energy in large amounts. And what's important is the scalability of present technologies. Can we scale up negative energy generators that I showed you up to large sizes? Can we explore new ways to produce it? Are there other methods to produce negative energy other than the Ford's Fader mirror? Can we scale those methods up? And then we're going to look at the Ford's Fader mirror itself, the parabolic cylindrical mirror, and maybe even new advanced laser photonics to maybe find new ways to increase the amount of negative energy that a pulse laser can produce. Detecting negative vacuum energy, that's pretty much what I described was the balanced Homodyne detector in a Casmir cavity. That has not been done yet. After all these decades since 1981, when IBM first developed the balanced Homodyne detector, no one has measured the negative energy in a Casmir cavity. So I'm the guy who's going to do it. I didn't predict it. A colleague of mine who's he's a Polish physicist. He's a postdoc at the University of Duisburg-Essen in Duisburg, Germany. And he published 2 peer-reviewed papers describing the balanced Homodyne detector needed to do a Casmir cavity experiment. And I'm collaborating with him. I brought him out to Texas, and he visited us over the 4th of July holiday in 2011. And we are working on building his experiment to test it. The next thing is to gain new insights by simulating FTL spaceworks. One thing is I told you about Einstein's general theory of relativity. That's 11 nonlinear partial differential equations, and the math is a bitch. So the best thing we've learned how to do this stuff is you can't do it by hand
Roll the
anymore.
dice.
The calculations can take years doing it manually. The best thing to do is use
between 1 and 100.
computer simulation modeling. Throw this stuff into computer numerical algorithms and simulation modeling for visualization. And there are packages available now that were invented by physicists and published in the peer review in the last couple of years. And those packages do exactly that. They've devised these packages for the purpose of looking at what happens when matter falls into black holes, how a black hole forms during stellar collapse, what happens when you go on the inside of the event horizon of a black hole, and the production of gravitational waves from a black hole as matter falls into it. So that package is actually the kind of package we need, and we've got that package. And one of the next things we're going to do, probably about 2 years from now, is begin high-powered supercomputer numerical algorithm simulations to do visualization of how a work looks when you try to build it. And the last important thing is lab experiments using what's called simulation or analog gravity. It's where you can do gravity on the tabletop in a laboratory using electromagnetic radiation. And what you're using are metamaterials. You're going to use metamaterials to reshape light. And you're going to reshape light in ways that will reproduce the effects of a warp drive or a wormhole. They've already been doing similar effects like that with sound waves to study black holes. And they're also doing that with light waves now to study black holes using a simulated experiment. Instead, you're going to create space-time in the lab, and you're going to bend that space-time. Only that space-time is not real space-time, it's electromagnetic radiation. Electromagnetic radiation can be treated like a space-time. It can be curved and manipulated and bent like a space-time. So you can get it to behave like a black hole or the planet Earth or a rotating mass or a warp drive in a wormhole. And so you use metamaterials to shape the space of electromagnetic light, electromagnetic radiation going around the metamaterial to create the effect of warp drives and wormholes. And that is pretty much the whole thing, I think. So is this going to be our future? That's the question. Thank you.
All right, guys. So the number was 35 that I rolled. Man, 35. Who came the closest now? Let's see. And by the way, sticky marks. Cheerio on the 5 pounds, mate. Much obliged. Wow, it's so 24. 43, I had 22.
Doesn't look like anybody got particularly close on that one.
Daniel, 38 is the closest, man. Nope. Mike Williams had 37.
Did he? Oh.
And that's right when I rolled it. It was right before I rolled it, too. It was like closer to getting rolled, too. You know, it's like we got to do like a quick roll and everyone guess it. We're going to give you 10 seconds. Ready? I'm going to start real quick, and we're going to give 10 seconds to roll it because it seems like the quicker we are to it, maybe that was what it was. All right, ready? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Wow, it's interesting how we had a lot of people guess things in the 50 range, and that was and it's literally I rolled 55. Cool. Cool, man. Yeah, 56, dude. That's pretty cool. That was pretty cool. A lot of people got close. A lot of people got close that time. Seems like the longer I sit there and shake it for, further away it gets, maybe. Interesting. Anyways, we'll have to try that again later. Not going to spend too much time on the dice roll. But yeah, this was a cool lecture, and this was on another one on unidentified aerial phenomenon. This is great. They have these in the archives, because that was a good one. Lots of interesting points there. Talked about this curvature, the stress energy tensor, and again, it's all about pumping 10 to the 33 or 10 to the 30th joules per cubic centimeter and cubic meter, or whatever, and how much we get it, how much energy we can pump in a single concentrated, so it's either like, we have an elephant stomp, right, and it's not even nearly enough force, right? So if you are to divide that by a smaller area, like the head of a pin, like that's why a pin is able to puncture things, is because it's so much force on such a small area. So we need either a pinprick to pierce this quantum vacuum, or we need, I don't know. You got any ideas on how to do this, Jeremiah? How do we shock?
As far as concentrating,
have you ever shocked the quantum vacuum with a Tesla coil? Do you think Tesla was shocking the quantum vacuum?
I guess what can I speak on this? Yes, I've shocked the quantum vacuum with a Tesla coil, to answer that question quite directly. Many, many, many times, and sometimes with more than one coil, and sometimes with more than one system operating. I've shocked it with a high voltage 160 kV DC negative output power supply with a very large amount of ground capacitance on it. I've hit the output with a voltage reversal physical contact wheel, 40 millimeters in diameter, spinning at 8,000 RPMs, which inverts the polarity some 8,000 times a second at some like 40 kV. So that's with a DC bias switching back and forth. That made capacitor plates glow like crazy. I mean, the whole plate's dielectric barrier discharge, and through the dielectric too. It was really wild. I have had ozone come out of systems which should not have any high voltage in them. I've gotten as much as, off the same exact winding, just a single 2-lead inductor, not a transformer. I have had output kickbacks in the back EMF range well over 25 kV from a 12-volt input. So I've seen a lot of weird effects. And as far as my view of the vacuum goes, there's something kind of funny about virtual particles, these partial charges or full charges that come into a state of rotating around each other and eventually, seem to pop out and release some radio energy while they're doing it. Well, those things never really go away. The actual physics says they don't go away, they don't annihilate, quote unquote. They continue to exist. And if that's the case, then you've got to think about it. If they don't annihilate and they continue to exist, wouldn't they be fucking everywhere? And wouldn't they be separable under the right electrodynamic conditions? How much energy is there in that pair separation and recombination? Think about it. So that's as far as quantum vacuum goes. That's what I would want to look at and try to find more data on, is about these pairs and what you can actually do with that energy, assuming that it's actually there, present in the void of the vacuum.
Interesting.
It's the kind of crap I see every day.
Yeah. What about that power supply that we tried to build that Marx generator, and it was just like with the capacitor banks that we.
The one with the bad cap in it?
Yeah.
Yeah, that was a shame. We didn't have enough time to locate the bad capacitor on the side of everything, but it really shouldn't be too hard of a job when someone gets down to it.
Yeah, that should be that would be cool. That's all that was wrong with it though, is that you think a bad capacitor.
Oh, we know for sure that it's at least one bad capacitor.
Yeah.
It could be more than just one, but I don't think it's more than two.
I think that's the reason those capacitor banks were thrown away. Whoever was using them were obviously
They were outrated. They were at the end of the lifespan. They were series configuration in the original setup. So, anyways, they should have been replaced. Obviously, at the end of their lifespan, that specification, even though they had redundancy within the circuit they were pulled from, clearly some of them were at the end of their life. And with a Marx generator, you're really slamming them about as hard as you possibly can. It's basically a dead short with multiple capacitors in series through that circuit. So it's gonna, if there's a problem with one of them, it'll show up in a Marx generator during a discharge. And it did. It showed up. So there it is. My assumption at this point would be, though, the one or two bad capacitors, once replaced, will probably yield the whole bank fully effective up to 1.5 megavolts. So that's with extra coil. Technically, it's rated for, I think, 960 kilovolts maximum pulse power without the amplifier coil, which we did not wind yet.
So, like, what? I mean, imagine like Tesla back in the day creating all these turbine generators.
I do.
That was just like on Niagara Falls, tapping the energy of the falls and then just using all that power to build the biggest freaking Tesla coils that he could just mess with.
Well, just imagine the looking in Westinghouse's face when Tesla said, if you let me run this big transmitter over at Wardenclyffe that I've built and you install the generator power so that I can turn the thing on, I promise that once I get it tuned in, I'll deliver more power than it takes to turn it on every single time I run it. And Westinghouse is like, I believe you. Take your word for it. And Tesla had power. Of course, Westinghouse was pretty pissed off when Tesla first booted up the tower and blew out Westinghouse's generators and blacked out part of the town. So Tesla went and, on his own merit, redesigned those generators for Westinghouse so that they could run his coil and he could pull ridiculous power from the ionosphere. Yeah, that's what he ended up doing, is rebuilding the generators that he had originally had a hand in designing, and was able to actually pull some, according to the reports, a white bolt of or plasma beam coming down from the upper atmosphere that roared like thunder at a low frequency. So, and apparently from 20 miles around, people were drawing sparks off the ground pipes, and within 5 miles radius, like horses were just galloping because there was little sparks arcing up through their hooves, and some ridiculous, stupid amount of power. Anyways, yeah, but he did deliver on that promise eventually. Once he got it tuned in, he did deliver more power every time he ran it than it took to run the alternators. So, and they were Alexanderson style alternators. So they, he didn't have a resonant transformer that was somewhere else in his system. The magnifying transmitter is only 3 coils. It's a primary coil, a secondary coil, and a conventional looking long, tall Tesla coil like what you're showing right now called the extra coil. But at the base, there's actually a very stout, stubby coil with only a small number of turns that sits directly inside of maybe a 2 or 3 turn primary coil, and that thing isn't ran off of a pulse discharge spark gap. It's actually powered directly from an AC alternator whose output is some 44 kilohertz, the resonant frequency of the transmitter. So it's designed to step modulate Earth's resonant frequency and hit the signal back and forth. And it builds up quite a bit of oomph when it gets going.
Yeah, if you want to know where this research they're looking at is being done, there's this facility in Milford, Texas, that's doing all this Tesla Wardenclyffe tower kind of research and stuff. They built a number of these things to try to transmit power through the air and run some experiments. But this is obviously just having fun.
I built a mini version of the Wardenclyffe transmitter. I showed you videos, I think, once of it. But anyways, yeah, it produced red sparks, and there was effluvia surrounding the entire coil. It was a kind of wild-looking thing when it was running. And when you would short it out, instead of acting like a normal coil where you just kind of get a super high impedance kicking back into the spark gap, because I ran a spark gap, it would send power straight through filament bulbs, and you could light up 200, 400 watts of bulbs in series on the output, and it just had no problem kicking the current, even on a dead short. So it's a pretty amazing little transmitter.
So there is an Earth frequency called.
There are several. There's the Schumann resonance, the most popularized Earth frequency of 7.6 something, I think.
Yeah, Schumann resonances.
Then you have multiple nodes of various Earth frequencies depending on the nature of the electrical signal being transmitted or the kinetic or physical signal. Think about it this way. Your telluric physical modulation of plates and tectonics is much slower. That's the transmission of sound through the ground. Your transmission of electrical signals and the electron drift velocity depends on the moisture of the ground and the conductive layer. So once it enters the mantle, it's going to transit a lot faster because everything is hot and all the electrons are already free in a plasmatic state of molten rock and metals. So but until it gets down there, you've got to get a high enough potential to cut through the Earth and get into the mantle to transmit along the boundary layer between the outer core and the mantle. And that's where you can get sort of these evanescent waves riding that boundary. They're very much like, polaritons. They ride the plasma boundary of the mantle.
Yeah, so it's called a telluric current. If people want to look this up, the science is not bunk. Totally not bunk, dude. Birkeland currents.
Those are critical. Those things can connect between planets, and you can ride them.
I wonder if those are like where you open the portals to.
If you had an option and they already existed in some geometrically located position on an Earth, why not use them? They're basically like a, like a tow line already sitting there.
Yeah, really. It's like airport time. This whole friggin' 60. Where is that? 78 degrees. The whole 78 degree parallel as turned into like prime real estate, buddy.
Oh yeah, until it shifts around there until you can make your own, right? Wouldn't it be nice to turn them on and off at will? It's possible.
That'd be pretty fascinating. Look at this between.
It's a lot easier to just get in the air though. And just go right over one, ride it up like a convection current, sort of like the birds do. Ride it up like a magnetic convection current.
Yeah. Well, then you initialize your warp drive in that space, and you can just carry it to the next.
Rotate some conductor against it, force it to twist, and you're going to be able to push on it.
I wonder if there's like a.
Think about it. It'll induce eddy currents. It'll induce like a Hall effect array floating over a piece of copper.
Imagine if
you
this
push against it by trying to twist it.
I imagine, right? If we're all in this like fractal infinite universe, and there's probably Birkeland current channels like connecting every body like this Earth to like, so that's like maybe the line along which they open these portals. That's just a thought, but I mean it's
a relevant one. I would agree. Not saying I know.
There's like all these different this parallel you can be at this certain time, and then that's when you can open up the portal. Oh,
watch it with sensors until the thing comes overhead. You're like, okay, there it is. Sitting there mapping it out. Have the cam pointed at it.
So let's find this out. Where's
like I said, it's a lot easier to use it if you're already in the air and you can just fly into it like a natural convection vortice just rising up.
So now we need like a whole system for calculating where the each latitude point on Earth will link.
Well, actually, what we really need is better detection mechanisms to locate where they are.
Yes. Yeah. Well, yeah, because it changes so constantly and stuff.
Exactly. So if you were already in the air, you could basically just choose to fly into them. Yeah, I would say it's virtually impossible to try and ground track it. They're going to end up over positions on the Earth that are probably, unobtainable as far as setting up equipment on. Like on the, on a super steep side of a mountain, or, maybe over the ocean, or I'm just saying there's a lot. If they're shifting around, you can't really move around anywhere else except for in the air freely. It's the only way you can really access the darn things. And the higher up you are, the more powerful they're going to be.
Yeah, so this is like this whole plasma universe theory that everything's like hyper entanglement connected, and interplanetary magnetic fields. Yes, this heliospheric current sheet, the three-dimensional form spiral that results of the sun's rotating magnetic field in the plasma. Oh wow,
That's wild. I mean, I get it's like an extreme exaggeration of it, but still pretty interesting.
Pretty fresh.
And I would agree. There are these invisible ripples within the magnetic and electric fields transmitted by the sun, as its various spots show up and disappear, and our orientation to that thing frame drags around according to gravity probe B. We have a frame dragging gravitational effect, which also drags our electric and magnetic field with it. So even the propagation of light and these particles that fly in from solar emission are all, trying to follow around and circulate in. And that's in a large part what's responsible for producing the magnetic field, which ironically protects us from the particles that are there to generate it. According to Feynman, it's 700 million volts, 400 million or 400,000 continuous amps, just flowing down constantly from solar particles hitting the upper atmosphere and hitting the ground. It's a kind of insane number. And apparently, if you deplete it, it just replenishes itself because it leaves holes for more particles to flow into more easily, so they don't bounce off. So yeah, a virtually inexhaustible source of energy if we just want to tap it. Just sitting there, a bit inconvenient to tap, but still just sitting there.
Hmm. Yeah, well, the SDR comes in handy here, right? So you could measure telluric currents on different frequencies, and you could also maybe build the transmitters to do that, to run it with a computer anyway. I mean, of course, you're going to have to link it to a bunch of other stuff if you want to have it set up to a Wardenclyffe tower, man. I don't know, but
I don't know. The one I built was only like 2.5 feet tall, and it seemed to work pretty darn good.
Really?
Yeah, it was 3 megahertz.
Should have you ever talked to those dudes down in Milford, Texas? Maybe we should interview.
No, I never talked to the BIGGG guys. But I have talked to DC over at Resonance Research before he died. We ended up getting his old parts and buying out a bunch of stuff that he had. And we now have the largest Tesla coil in the Midwest. We used to do shows for the local Maker Faire. I think some people are still trying to pull that off. Right now, I'm just way too involved with the gravity research, so I don't have time for the Tesla shows anymore. But yeah, we used to run around jacking out 12-foot lightning bolts and making kids cheer. So, I mean, it was a crazy freaking show. Parents terrified, wondering if their families are being exposed to something dangerous because the lightning show is spectacular and it's loud. It's one of those funny things, man. Used to do Halloween shows too. That was kind of fun, but not anymore. Now I'm just basically concentrating on producing forces with no reaction. That's my main, pull.
Like, does your cell phone still work? Then there's no...
Sometimes, not consistently.
Interesting.
I don't know too many people that are deep in this research who have digital devices which are not hacked.
Xenic surface waves have not yet been experimentally observed. And this is unique in that it uses the technology, only uses these surface waves as opposed to radiated waves. Yes. So the Xenic waves, key.
How different? I mean, how different really are Zenek surface waves from evanescent waves, if you think about it?
This is soliton.
Right. So, well, here's the funny thing: we have observed evanescent waves experimentally, and as far as I'm concerned, they're pretty much the darn same thing as Zenek surface waves. So, compare them side by side. Really, what's the difference?
Okay.
These are electromagnetically or electrostatically induced wave fronts that ride along the surface of a boundary between, say, a conductor and a dielectric area, or two different conductors, or two things with a different refractive index. They're part of the explanation of why fiber optic cables work, why the tiny difference in refractive index of as little as 3% between the outside jacketed cable and the inside jacketed cable, both made of the same material, but one of them with 3% dopant, can actually keep and capture the photons traveling through the cable. Are because of these things hitting the surface and producing a counterpoise field that allows the photon to travel along, basically without the losses. But anyways, you look at that and you compare that to a variety of other wave effects on the surface of metal conductors like plasmons, and then they're really not very different. So maybe it's just a naming convention for why they haven't been observed yet. Maybe they have been observed by a different name.
So this whole idea of this surface wave on like a ripple on the water, you know, like the boat, like a boat creates this like triangular wake in the water that trails behind it. It's kind of like this idea of that wake is a type of wave.
Yeah,
that
it's basically like a bow shock in space time. If you really want to consider it something, it's like a bow shock in a field that's part of space time. That field could be the electric scalar potential. That field could be the magnetic torsion tensor. That field could be the gravitational constant. That field could be a lot of different things.
It could be a bunch of negative energy states that you're pumping in front of your craft.
Well, an expansion of the gravitational constant locally is the same thing as negative energy. Any physical matter or mass that's inside of that field is going to experience a negative energy state. So negative energy is just a matter of perspective from one frame of reference to the other.
Fascinating stuff, man. All right, well, this was a great discussion and a much deeper dive than that shallow video from the 60 billion a year funded mega conglomerate. But anyways,
never got that photo, Dan. Gotta send that over again.
This is great stuff, man. And Dan's gonna come back on at another time, and we're gonna do like a whole thing on John Lear for sure, man. Dan's a real good friend of mine, and can't wait to
I was talking to a slightly different Dan there, but either way, yeah, I agree with you though. You guys should definitely do a dissertation on Lear and get into it.
Oh yeah, get into the real truth about Lear.
Yeah, come on, man. Meat and potatoes. That's what everybody really wants.
This is great because like Jeremy Corbell is trying to capitalize on the man's death and like just milk it for everything it's worth. Like and it's just.
Don't worry, the scumbags will never let a good tragedy go to waste. Guaranteed.
Yep. Yeah, well, this is why we're here, man. Really dig in. All right, cool stuff, man. I can't wait to do more experiments with you and Mark, and we're gonna get into that this year for sure.
Yeah.
It's already too late. I should get down there, and I got a couple ideas stuff that I want to try based on some of these ideas that we've been talking about and how to build some of these metamaterials in our lab.
Run them by me, man, because I'm building metamaterials already, so you might as well. You might be surprised what I can pull off here.
Yeah, well, there's some stuff that I don't want to share, like completely.
Not live. I'm just saying, man. Talk to me about it. Don't be afraid to contact me about it, because I probably have a lot of the stuff already necessary to do it.
It's cool to talk, but you don't want to really into the secret sauce. You know what I mean?
Well, I know, man, and we know, like I was saying the other day. Got a pretty good idea about the secret sauce at this point.
You have to leave out the secret sauce. Can't.
I left out some of the secret sauce.
Every time, man. You gotta clip it. You gotta get that on like
This is
some
a
easy
classic.
push button radio show.
I recorded it and downloaded it already, so I have it. But I keep having to go back because it doesn't play the audio when I do it, right? So, you know, I have it on a clip already, but it doesn't work. And
Damn.
I left out some of the secret sauce.
Yeah, that's key.
Yeah, that's one of those precious clips that retains its value every time you see it.
That's gonna. I'm gonna make it this soundboard thing. It needs to be. Well, people have already done it, like made the GIF out of it and stuff. I was just like, oh, this is great. He must have known about the secret sauce because, like, I don't know how.
Dude, link to the GIF, man. I'll authorize that thing. Go
great.
on, post it.
It was a great soundbite, man. I love it. Anyways, thank you all for watching. We're not going to go beyond 2.5 hours. This is ridiculous.
Oh yeah,
it was fun as hell.
I will show one last thing. Yeah, the newest iteration.
Oh, you got some stuff to show?
Oh, it's this thing. So that's the little rectifier chain that's going on that replication gravity flyer. I found that I can pump enough power from the Tesla to not need DC high voltage elsewhere, but I do have to ground one side of that thing. So otherwise, yeah, it's waveform clamping. It's just designed to resonate between the two plates and the center disk, and the rest I'm not going to get into. But otherwise, it's a pretty different design. It doesn't look a lot different. I've got a lot of different parts in there that are significantly modified and upgraded from what he did. So hopefully we're going to get a bit more than just its own weight, but we'll see.
Sweet. Thank you, Chris Spaghetti, for the $1.99 super chat. Much appreciated. And can't wait to see you next time I come down to the lab. He should definitely, I'll let you know if I'm going to New Jersey anytime soon, maybe the end of the month, because I got a couple jobs this month, and then the end of the month I'm planning to go to Tim Pool's house and do some work with him, because help him build Predamus down, and this idea and the lab part of it, this whole, he wants to get down on funding some of this stuff. I mean, it's high risk, infinite payoff investments, but we got some ideas about how to do this. In any case, send me some stuff, the alien scientist at gmail.com, and thank you to Jeremiah for joining me, and I can't wait to see what you got. Let's make the GIF of it with the subtitles and whatever. I want to put this.
Just keep getting in deeper about the stuff you've already covered on your last few episodes, especially that nice animation stuff you said there was kind of pivotal, kind of critical. Definitely something you want to cover more about.
Ideas. I want to explore some of these ideas further, because it's just.
You should.
It gets into.
You're gonna find a lot of interesting stuff, man. It gets kind of wild.
It's all connected, man. It's all connecting. And if you can't connect it, and then that's your problem. You won't get the current, and you won't get the impedance match and the current flow. Right?
Yeah, man.
All right, dude.
Well, surprised how much current is actually flowing in that field there. Between those discs and the capacitor plates, it's a rotating current. There's a lot of power.
And when you blast that enough energy into a small amount of space, you get you get plasma first, and there's another level beyond that, right? That's like that.
That's the charge separation. Yeah, that's the good stuff right there. That's what you want.
That's what you want. That's what you want, brother.
It's a secret sauce.
It's a secret sauce. One more time. Oh, I closed it already.
One more. Oh man. Damn.
I can bring it back. Hold on.
sauce. Can you talk around it? I left out some of the secret sauce.
Hold up, I gotta put it back in.
I left out some of the secret sauce.
Yeah, never
I
gonna
left
get
out
old.
some of the secret sauce.
Secret sauce. We gotta make like, dude, like, why is we gotta like get those guys from the remix, the guys that do the remixes to
I do remixes too, so man, I might throw
we
that
should,
in.
we should like take
Dude,
this.
splice that audio clip and send it to me by email, and then watch what I do with it.
We gotta get a couple of these clips from like key stuff that he says, like the super force, you know, like we'll make a whole rap, dude. That would be awesome. I think we should do it.
I agree.
Down with it. I'm gonna clip it up and start working on it.
I'll scratch it out.
Yeah, he has the passion, dude. Yes, dude. It's classical. It's classical. Can't wait. It's gonna be awesome. I have the timestamps in there. There's plenty of like key stuff. So all these little timestamps, go down to my comment and make sure you thumb it up. And hell yeah. I get a fragment of the Roswell craft. Oh yeah, that was a Bob Lazar didn't really send me that. I was just that was an April Fool's joke. It wasn't a real piece of element 115. We're just joking around.
Yeah, man. Where's your Linda Moulton Howell fragment, man? Aren't you supposed to have one by now? Didn't you go out in the desert and find one? Come on.
We scanned out. Maybe we didn't go to the right spot. I don't know. Oh, this was his April Fool's announcement. This was hilarious. If you want to go, if you missed it, go check out.
Clean.
Go
oh,
check
man,
it out.
I didn't even see this.
Should we play it before we end? No. I don't know. I'll just let people go.
For the
watch
sake of criticism, he might let you get away with it. Your channel is kind of related. I don't know. You think you'll get flagged for it?
He won't flag me. No. He's
No?
cool.
Well,
No,
all right, man. Then yeah, I haven't seen this yet. I haven't seen this.
Dude, he was so like cool with like all the great questions we've been providing him with for his guests, and like all the great feedback he's been getting as like an interviewer for asking such great questions. He like made me a moderator on his channel, so like thumbs
Awesome.
up on that. That's key. He's Kurt's the man, so for sure. Yeah, this April Fool's joke was amazing. Let's you want to watch it and have a laugh?
Yeah, I kind of do.
Let's all do it.
Click on the timestamp in the description to skip this intro. Then read the comment section of people asking for the timestamp to skip this intro. Firstly, huge announcement. Bob Lazar has donated element 115, and I heard that Jeremy Corbell is working to stretch this 10 minutes of content into a 3.5-hour documentary. Personally, I'm looking forward to it being narrated by Mickey Rourke because I don't think I have enough thoughts of what is going on already floating around in my head. Secondly, there will be new thumbnails out with the old images and in with the cutouts of Kurt in a provocative pose with the guest and the contrived white borders with the red arrow. Since that's not overplayed on YouTube, why not achieve the equivalent of mind uploading and give my soul to the algorithm? In that vein, I'm going to make sure that I say like this video and smash that subscribe button. Call to actions, ending videos with, so what do you guys think? Leave a comment below about something vapid that wastes everyone's time for the sake of demonstrating engagement to the platform. More reactions to memes with guests. I think that the popularity of the standalone meme clips more than justifies the degradation of the character and self-respect they bring to a channel. We'll also have different types of reaction videos. So, for example, Sabine Hostenfelder reacts to Eric Weinstein trying to explain a point without jargon and irritation that people aren't understanding, that the DIN is a sense-making smooth structure on a fiber bundle over the space of the twin nuclei problems of the Sheab operator's pullback of the n-squared revolutions. Linda Moulton Howe reacts to Kurt's leather jacket. Leo Gura reacts to antipsychotic medication. Also, for every one podcast, I'll snip about 6 clips of it and post it to the main channel to increase view counts at the expense of cluttering your feed, because you don't necessarily need to associate quality with every single post on this channel. That's ridiculous. you can skip it if you don't like. I mean, you can skip everything except the Patreon and the sponsor requests, which will remain approximately 40% of the video. Another announcement is that there will be more pushback from Kurt, especially toward the guests who repeatedly admit that their interpretation of quantum mechanics is not testable and that the data that they have is anecdotal about something. Perhaps there's an NDA involved, with me repeatedly saying, okay, well, where's the evidence? And then smugly lean back as they admit in self-defeat, oh, Kurt, wow, you got me. What a brilliant question that I've never considered before. I will then follow suit with a liberal use of the word grifter and writhe in my own self-importance anonymously on social media. Another announcement for the Ask Me Anythings, the more sober and ordinary the username, the better. Alien Alcoholic asks, have you heard of facilities that are housing live aliens? This question comes from Poop Dig. What does he think? I know. This question comes from Dom Talong. Question to Ross from Euphoric Gur 4674. As a journalist who understands,
where do you get all these names?
And of course, priority will be given to Alien Smegma Collector, which, by the way, I just found out is McWest's pseudonym on Animal Crossing. On this theme, if you want to hear what the other theologian guest has to say, then you're going to have to pay for a premium.
That's too perfect, man.
People
I mean,
always
he
get
nailed it so good.
This isn't the thing, and they never bother to look at the
The stuff that we all thought but never said, but should have now in hindsight, right?
Recently, I've come to several conclusions, like that the fringe is indeed misinformed and the innovation will come from the conservative center. On this account, I think string theory is probably correct. Many worlds is probably correct. That Area 51 picture of an alien is indeed genuine. I think real aliens show evidence of polygon edges and clearly pixelated texture maps. I've also realized that I need to stop smiling so much. It's a bit off-putting to the guests to be so welcoming and amiable.
The witnesses described that we hope eventually
systole and diastole, if you like, so from the heartbeat.
Consciousness than anything else, though I knew it was the superset. And about 2 years.
I'm also going to be ramping up the amount that I say this podcast is technical 4 times in the same 3-minute video, because I don't think my introductions are stilted and verbose and pompous enough.
The first hour can be rather technical. In these podcasts, we tend to delve into intricacies, into equations, sometimes into meticulous technicalities. If you've surveyed this channel before, as we've done an unduly technical dive into Donald Hoffman's research papers.
Also, to reflect the UFO content, TOE will be rebranded as UFTOE, and logos will be changed to a picture of myself phlegmatically staring at the camera. It is, after all about me and not the subject. Lastly, there will be more of me pensively looking off onto my desk at some unseen object as if I'm silently having a profound insight, but I'm truly thinking about if my poor wife has used up the plastic cups we set aside for her to urinate in, because this is the only bathroom in our condo, and I'm 4 hours into this podcast live. You know what? I don't think I've imitated Jordan Peterson's mannerisms enough this year, so I'll be working on that as well. Thank you, and I hope you enjoy the upcoming changes. Now hold on while I observe the chat explaining to people that premiering isn't the same as live streaming.
Damn. Oh, man, that was gold.
This podcast is now finished. If you'd like to hear me supplicate for another few seconds, then continue listening to my 100% not repetitive plead for donations. It's support from the patrons, aka the splendid and munificent, and the sponsors, aka those brave enough to invest in a channel on mathematical physics, consciousness, and God, teetering as close as you can to being Deepak Chopra without being Deepak, that allow me to do this full time. Every dollar helps tremendously. Thank you.
Yeah, you nailed that one, man. Couldn't have said any of it better. That was perfect.
And then like it just shows you like when with everything Corbell's done now that John Lear is dead now, it's just icing on the cake, man. That's just awesome. It's gold, dude. It's like
yeah. Aquino's theory of everything is a lot stranger than this show, that's for sure.
You know, that was so well written. I got to think more about how I'm going to write the script from the movie that I'm going to be working on a documentary. I hopefully here soon with the same guys I did the TR3B documentary with, the same director, and I want to make it about the whole history of the anti-gravity research and really do like a whole dive on some of this, some of the stuff that we talked about today. But we're going to try to go and visit the actual places and try to get more archival footage and more trying to piece more of this puzzle together in the process. So I think that would be really cool to, because I have a whole, if you guys want, if you go to alienscientists.com and go to /technology, right? There's a whole page that on my website where I talk about like tons of anti-gravity, papers and history and just stuff on it. So go check that out if you guys are interested in anti-gravity research, and come to the right place. That's what we do here. We talk to the pros about it. So Eric Anderson, would love to interview you, man. Not tonight. I'm too tired, but definitely email me, thealienscientist@gmail.com, or message me on the contact page. And yeah, would love to hear from you, man, and would love to get you on sometime for an interview. And anybody
Stick
else.
around a minute after the show too, Jeremy. Let's hack out some metamaterial discussion.
Yeah, if you want to jump on. Why don't you jump on right now and let me know what you know, and come join the chat backstage. So there's the StreamYard link. Come join us backstage, and we'll talk about getting you on for a future podcast. Later, guys.
Dude.
Peace. Have a good night.